In this video, we'll concentrate on locating absolute extrema on a closed interval. And the beautiful thing about using a closed interval is that by the extreme value theorem, we are in fact guaranteed to have absolute extrema in the form of minimums and maximums. And so that's kind of nice there. So we know that we have to come up with a minimum and a maximum. All right, so how do you do this? You do it in really kind of two steps. One, we want to evaluate the endpoints. Okay, and what that really is we want to look to see, all right, what are the values at those endpoints on the closed interval? Because those could possibly be maximum and minimum, as we'll see with this first one. The other thing that we want to do is we want to check all. All is the key word, all. Okay, critical points. And now we had a theorem that said if you have a relative extrema, then it occurs at the critical point. That doesn't necessarily go backwards. If it's a critical point, it's not necessarily a relative extrema. And so be very, very cautious on this. Now we can utilize that to some extent because we know that if an extrema exists, then it's a critical point. So if we check all the critical points values and decide, then we can use that to decide if it's relative or not. Okay, and so we'll be checking that on the open interval of -1, 2 in this particular instance. We can't check the closed interval because it doesn't work with relative extrema. Okay, so first things first, let's check and evaluate the endpoints. And so I have f of -1 is equal to 4, 8. Okay, these are things I'm assuming that you can do fairly readily, so I'm not going to spend a lot of time doing it. 3 minus 2 is 1 times 2 is 2. Okay, so those are our two endpoints. Now we want to check the critical points, which is where either A, the derivative is 0, or B, the derivative does not exist. So if we find the derivative, we find that this is in fact 6 minus 2x. Our derivative is -2. All right, so where are the critical points? Well, when does 0 equal -2? It doesn't. So there are no critical points. All right, so simply look at the endpoints then. This is the maximum. It's the absolute max. So we have absolute max at the point -1, 8. And we have an absolute min at 2, 2. All right, and that's it. And we're done with the problem. It was just asking us to find any absolute extrema. So we did. They happen to be the endpoints because it's a linear function. All right, let's continue on. And let's try one that's slightly harder. Okay, so first we're going to look at the endpoints. So evaluate the endpoints first. I always try to do, whenever I attack the same style problem, I try to do it in the exact same way. That way it's less that I've got to remember because I'm always doing the same thing day in and day out. All right, so f of -1 is equal to, I'm going to start over here on the square. So that's 1, that's 3 halves. -1 minus 3 halves is -5 halves. Okay, f of 2, this is 8 minus 12 over 2, which is 6, which is 2. You can use your calculator on this as well. I just typically don't because I find that using calculator is actually a little harder and slower. Check my math though every now and then I'll make a mistake. All right, step 2, we got to check the derivative. So all critical points. Check all critical points. Critical points occur where the derivative is 0 or where the derivative doesn't exist. This is a polynomial and therefore it's differentiable everywhere. And so we say the derivative is equal to 3x squared minus 3x. We're just using the power rule on that. And so 0 is equal to 3x squared minus 3x. We can pull out a 3x from both. And so we get, after that, we get x minus 1. And so we have x is equal to 0 or x is equal to 1. So let's check it now. If x is 0, what is the y value? Okay, so f of a 0 is equal to 0. F of 1 is equal to, well, f of 1 is 1 minus 3 halves, which is a negative 1 half. Okay, so now if these are relative maximum or minimum, then they occur at critical points. So now we have to check all of them. Okay, so we look at first f of 0. Is that a relative max or a min? And I'm not seeing that it necessarily has to be, but it's certainly not any bigger than our endpoints, and so it's not an absolute, which is what we're really looking for. And neither is f of 1. And so our endpoints, again, are our absolute max and mins. Okay, remember, we're looking for the absolutes. And so we wanted to find out, are these any smaller or bigger than our endpoints? And they're not. Okay, so we have an absolute max at 2, 2, an absolute min at -1, -5 halves. Okay, I'm going to do a couple more in the next video just to kind of cement this and make them a little tougher.